Welcome back, guys. This video will be absolutely wild. I mean, you can see this already regarding to my hair, but in this video, we want to do something which is not 100% related to Android app hacking. But I mean, nevertheless, come on, let's have some fun over here and let's have a look how we can analyze a Bluetooth Low Energy connection. Why is this important? Because normally we've got our device, in this one for example, and this is making an HTTP or HTTPS request, I hope it's HTTPS, to a web server. So this device is using the Wi-Fi connection or the mobile carrier network to perform this network request. And this is something we can easily sniff. We will have a look into this in the man in the middle section. But nowadays, we are not just dealing with apps and servers, we are also dealing with a lot of IoT components. For example, this toothbrush over here. I mean, you can see I'm not using it very often, but it would be important to use this. So this toothbrush got an app and they are communicating via Bluetooth Low Energy. The question is now, how can we analyze this connection? I mean, this is not in web traffic right now. This is Bluetooth Low Energy and we cannot have a look into this connection because these are radio waves. An easy solution for this one would be logging the traffic that the application is receiving and sending to this toothbrush on the device. And this is exactly what we do in this video over here. And then we can use this knowledge to also extend this to other devices. For example, to this one over here. This super annoying fluffy little Furby. So are you ready for this? Then let's have a look. Alright, back at the Ubuntu VM, the first thing we want to do is enabling the HCI Snoop log in the developer option. And therefore we need to have a real device. I mean, not to enable this, but later on to communicate with a Bluetooth Low Energy device, because this is something we cannot use in an emulator. The Bluetooth protocol cannot be emulated and sent out to a real device. That's not possible. So in case if you want to play around with a real Bluetooth Low Energy device, I mean, you nevertheless have to get a smartphone, right? Yes, absolutely. Okay, so let's do this. I plug this into the computer. All right. And then I can use the terminal to show you the screen on the smartphone. So running screen copy, there we have it. Oh, by the way, I did change the desktop background. So let's put this on the left. So the black background was not that nice to view regarding to the smartphone. So therefore I have chosen it a little bit brighter. Okay, so let's enable the HCI Snoop log. We go into settings and then within, let's see, the system, advanced, developer options. So here we have them. And then I'm searching for Bluetooth, okay, HCI. There we have it, Bluetooth HCI Snoop log. Let's click on this. And here we can see it's being disabled. So let's click on it. And here we have now two options, enabled filtered, but we do not want to have filtered. We want to have everything. So we choose enabled. All right. And that's all. The only thing we have to check is that Bluetooth has been enabled. Yes. So this is all we need to do to create this log file. So now all these Bluetooth connections will be logged into a certain file, which we can then later pull from this device and use it within Wireshark. Awesome, right? So let's see. As already mentioned, I've got this toothbrush over here and this one has an application. And no, I'm not getting paid by Oral-B to show all of this. But I think having this toothbrush over here illustrates this pretty nicely. So this is let's say an IoT device and this one is communicating with a real smartphone based on Bluetooth Low Energy. Alrighty? Okay. So if I open this application, let's see. We are greeted and we can see connect to a toothbrush with this app and brush like a pro. I mean, this sounds absolutely awesome. Let's do this. Let's click start. First, allow location services, of course, but this is unfortunately something that comes with Bluetooth Low Energy. So that's unfortunate permission we have to use quite often regarding to this one. Okay, only this time. And connect your toothbrush, all right, start. And now all I need to do is pressing this power button. Found. So we can see this toothbrush has been now connected to this real smartphone over here. Amazing, right? Okay, so we can go ahead. Ooh, let's see. Terms. I'm at least 18 to brush my teeth. All right, sounds pretty ridiculous. Let's brush. Okay, Now, if I press this power button, then we can see this pop-up appears and it's super annoying loud. So we can see pause brushing, session ends in something like this, and we can also, let's see, no, it has to be on, okay? So I'm re-enabling this. We can see reduced pressure. I'm brushing way too hard my teeth right now. All right. So all of these information are being transferred via Bluetooth Low Energy to this smartphone application, to this one over here. And yes, now we want to analyze them. So we have logged every single request right now, and now we can pull those data from this device and analyze them in Wireshark. Awesome, right? So let's see. Okay, to do this, we need to get the HCI SnooPlog file from the device. And unfortunately, this is sometimes a little bit ridiculous hard. So it depends on the manufacturer, the device, and also the version where this file is being stored. But I've got an easy solution for you. The easy solution would be creating a bug report, and this bug report includes this file. This bug report also contains a lot of other information which is not really necessary or relevant for us right now, and it costs a little bit more time generating this, but at the end it's the easiest way to fetch this file. Alright? Okay, so let's see how we can do this. Oh, I need to brush my teeth a little bit longer the next time, but I'm even glad that I'm using this device right now, so this application shouldn't complain. Alright, so let's open a new terminal. And then I'm using ADB bug report, and then I need to provide a file name. Let's call this brush.zip or brush_report zip. I mean, as already mentioned, this is not just the Bluetooth HCI SnooPlog report right now, this is everything. It's also interesting to have a look into this one, but I guess right now let's focus only on Bluetooth. All right, let's hit this, and yes. I also got a little vibration on the device, but it automatically starts. This might take a few minutes because a lot of information are now being gathered, and I will fast forward this process that we do not have to wait that long. Alrighty? Okay, so here we are back. I guess it's finishing pretty soon, but don't get fooled by this status bar over here, because it immediately jumped to 93% and then it got stuck for a few minutes right now. Okay, so let's see. In this file, by the way, there we have it. If we are using ADB bug report and then the zip name, this one is being executed from our host system. So the ADB command is connecting to this device, creating this report, and automatically fetching it on our host system. So wherever we have started this ADB bug report, there should be now a file named brush_report.zip. And let's see. Yes, here we have it. So we can see it's 5 MB large. Let's extract this. Okay. And here we've got now tons of information. So this is sometimes also useful for applications because we can find a lot of things. We can see crashes, application states, and much more. Right now we want to focus on the HCI SnooPlog, and to be honest, I guess it's within FS, but I'm not sure where it is here. So let's see. Proc, by the way, yeah, that's the memory. So every ID, it's the process ID, and we will find memory information of this process. So pretty awesome, but back to this one. So I'm now in the FS directory, and I'm simply searching for HCI. And here we have it. It is within data misc Bluetooth logs. So let's go into this directory maybe. Whoops. Data misc Bluetooth logs. Yes. So here we've got last and we've got this HCI log. This is now a file which can be directly opened with Wireshark. So therefore let's see. Let's perform a right click, open a new terminal, and now let's use Wireshark on this file. In case if you do not have Wireshark installed, it's pretty easy. We can simply run sudo apt-get install Wireshark, and then it will be installed. I guess the only question that you have to answer is if you want to allow capturing packages for root users or also for normal users. So normally I start Wireshark with root privileges, and therefore I select just for root. But running Wireshark as root can be also pretty dangerous. Wireshark is a package parser, and if you run this in a not trusted environment, it can be possible that an attacker sends a encrypted package and compromises your host based on Wireshark. In the past, there were some exploits which demonstrated this behavior, but in my case right now, I'm running this on a virtual machine in my trusted environment, so therefore I'm pretty confident starting this as root. All right? Okay. So after installing Wireshark, we are now using Wireshark on this BTN GNU block. And here we have it. Awesome. So this is now the whole communication between this toothbrush over here and this mobile application. So all these packages that has been exchanged between those two are now in front of us, logged in this file, which can be opened in Wireshark. Absolutely awesome, right? So now we can investigate which data has been exchanged, and we might be also able to manipulate or interfere with them. Let's have a look. All right. So if you're looking at this file, it looks a little bit strange because normally if you're opening a file with Wireshark, we expect some IP addresses because this is where we normally use Wireshark regarding to analyzing network connections. But now we are not analyzing a network connection which has a source and a destination IP address. We are now looking at a radio protocol, at Bluetooth Low Energy. But the good thing is that all these bits and bytes which has been exchanged between those two devices can be interpreted by Wireshark. So Wireshark is fetching all these bits and bytes and passing them into those Bluetooth headers, which makes the analysis a lot easier. All right? Maybe not, but nevertheless, let's have a quick look into this one. So the good thing is everything between host and controller can be simply ignored. Nice. So we have to scroll down to find our connection. And let's see. Here we have it. All right, let's scroll up a little bit to find the first package. Okay, I guess it's this one. And it's even more amazing because Wireshark is showing us that this is now the source. This is our Pixel device. How does Wireshark know this? Well, we can see HTC and then we can see 3 bytes. So the MAC address consists of 6 bytes. And the first 3 are regarding to the vendor ID, which means in this case HTC. So Wireshark knows, okay, that's an HTC vendor, and this one is, it's known for a Pixel device. The last 3 bytes are being shown over here. So these are just the last 3 bytes of our MAC address. And the same, of course, for our toothbrush. But now it's a little bit strange. Why do we have Texas Inst over here? I mean, we can see those last 3 bytes, but what is this? Once again, this is the vendor ID, which means this toothbrush has most likely a chipset in here from Texas Instrument. So Wireshark doesn't know that this one here is a toothbrush, but Wireshark knows, okay, the chip in here is from Texas Instrument, so therefore it's displaying these information. Also pretty awesome. I mean, without opening this device, we now know that this one has a Texas Instrument chipset in here. All right. So further investigation, we simply just replace in our mind Texas Instrument with toothbrush, okay? Okay. But now it's getting a little bit rough. I mean, this course over here is designed regarding to Android app hacking, finding and identifying vulnerabilities in mobile applications. We are now looking at the Bluetooth Low Energy connection, which is not 100% related to this course. But nevertheless, Bluetooth Low Energy is all around us nowadays, and it's often used in IoT devices, and those IoT devices often also have a mobile application. So it could be the case that a vulnerability within this mobile application can be exploited based on a Bluetooth Low Energy connection. And therefore I would like to cover it in this video over here, but only on a high level. So we do not dive too deep into this. I just want you to enable to understand what's going on over here in this connection, that you are able to identify and also exploit this on your own, so that you can identify those vulnerabilities and send them to the vendor that they can be fixed. Okay? All right. As already mentioned, Wireshark is able to pass these packages while we get all this information within this info tab. And this is absolutely nice. And for example, over here, we can see the source, Pixel device, destination, toothbrush, and this one is type request. So our smartphone is requesting something from the toothbrush. We do not know what, but we know it's a type of request. Okay. Then we can see we've got get primary service declaration. And this is something I would like to discuss on the graphic tablet in a little bit more detail, because there I can explain it way better than here right now. For now, get simply stands for generic attribute profile, and it's working in the following way. If we're having a mobile application, this mobile application is asking this device, hey, what services or characteristics you offer. Those services and characteristics are simply just information. For example, the information how long we are brushing, the information if we are brushing too hard, the information if we have switched the mode of our brushing routine, and things like this. So these are just data which can be requested. Okay? All right. Then let's have a look. Everything between controller and host can be ignored. This means here we are having now as source the Texas Instrument, so the toothbrush, and this one is now responding to our request. So this is the response regarding to our request. And this one is now answering with all these information we have asked before. Okay, let's scroll down a little bit. Because here we can see those packages. I mean, we've got the timeline on the left. Those packages will be sent more frequently, which means this could be the routine where I have actively used this as a brush. So therefore, okay. This one, for example, source is the toothbrush. This one is now sending a response. And let's make this a bit larger. Yes. So here we have now a lot of things. So we can see we've got something with get, characteristic declaration. We will have a look onto this one on the graphic tablet. Then we can see properties, write and read. So we can write and read from this characteristics. And then we've got this long UUID. And so if we understand this package right now, I guess we have a good understanding about the Bluetooth Low Energy. Therefore, I do not want to dive deeper into those packages. We just take those information with us on the graphic tablet. We can see we've gotten get characteristics. This one has some properties, write and read, and we've got this long UUID. We can also open this one, but yes, it's not providing any more information. We can just find a service UUID beside this characteristics UUID. All right? Okay. And now let's switch to the graphic tablet, and now let's have a look what all of this information means right now. So therefore, let's go. Back at the graphic tablet, I really had to get rid of my sweater because now we are doing some hot stuff. Okay, no, I'm not going to make this joke till the end. All right, so back at the graphic tablet, now let's have a look at this connection. On the left, we've got our well-grown smartphone, this one. Smartphone. Okay, and on the right, I mean, could it be even more exact? I give you this example. Could it be even more exact than this one? Absolutely not. So no further label is being needed, but nevertheless, let's also name this toothbrush. It just took me, I guess, 1,000 attempts, and we have to deal with this one right now. Okay, so the Bluetooth Low Energy connection consists of a server and a client. The server, this one, is advertising its existence to the client, which is in our case right now, the smartphone. But during a connection, this could also change. I mean, the server can also interact as a client in the same connection type. So it doesn't mean to be that the server always stays the server. But let's make this not more complex right now. So the server is advertising its existence via 3 different channels. This is important. Okay, why is this now being important? Well, if we're using a smartphone, it isn't. But if we're using an external device, for example, this one over here. This is an Ubertooth, and we can see it has a large antenna because the Bluetooth Low Energy is on 2.4 gigahertz. So this device is capable of sniffing Bluetooth connections near around me right now. So I could listen to those connections, and if they are not being encrypted, then I can see all the data and also interfere with them. The problem by using an external device is having those 3 advertisement channels. Because if we are listening on the first one, on this one, with our Ubertooth, that's an ear by the way. Okay, it's definitely an ear. So if you're listening on the first one and the devices are using the second advertisement channel, then we are not sniffing anything. which means we need to get 3 of them to make sure that we really fetch this communication between those devices. Or what I did in the past, I did run 20 times the same task to make sure that at least one has been successfully completed, captured. If you're using a real smartphone, we can completely ignore this. This is just a hint if you're using an Ubertooth device and sniff a Bluetooth connection and wonder why is there no package in here. Okay? Alright. So luckily we are having a real device and therefore we do not need to take care about those 3 advertisement channels. By the way, besides these 3 advertisement channels, the Bluetooth Low Energy protocol is in total using 40 channels. Which means 3 are being used for the advertisement. 37, quick math, are left for data transfer. Okay? Okay. So right now we do not need to take care about this one. But this information is super handy if you want to sniff in connection with an external device. Alright, let's clean this. Okay, so now we have our smartphone and the toothbrush, and the way the communication works on a high level is as follows. So if we turn on this toothbrush, here we can see it's being pressed, then this one is advertising itself and telling everyone I am here. Alright, the smartphone, which is the client, needs to scan for those devices. So the smartphone needs to look if a toothbrush is near around us. I mean, we can identify those toothbrushes based on the vendor ID right now. But it could be also the case that we are having a different device with a Texas Instruments chipset and it's not being a toothbrush. Therefore, we're getting this information within this mobile application. If we are really connecting now to our toothbrush, it could be also a different device or another toothbrush. So this information over here. Okay, after connecting to this device, the smartphone is now requesting information from this toothbrush. So the generic attribute profile. And profile within the toothbrush, it's just a known set of information. For example, this toothbrush has a profile. So this is the profile. Okay, within this profile, we are now dealing with services. And within those services, there's only one left, then we are done. Within those services, we are now having characteristics. Okay, so I hope you can still read this. And characteristic is simply just a data type. So it could be the information about the brushing time, the brushing mode, the brushing pressure, and things like this. Everything related to brushing could be summarized within a service. So to make this a little bit easier on the right, let's write this in the following way. So let's clean it first. Okay, so we are now having several characteristics. For example, one could be brush mode. One characteristic could be brushing time. And one characteristic could be also the brushing pressure. So brush pressure. Okay, so this one, it's pressure. Okay. All of them have something to do with brushing. So they can be now categorized, or let's say summarized, within a service. So a service can have many characteristics, and a characteristic is just a set of data. For example, brush time. So these are now those characteristics. Okay, if the smartphone is now requesting data from the toothbrush, for example, about the brushing time, then it has to ask this characteristic. And to ask this characteristic, we are having this UUID. This UUID is this long identifier based on hexadecimal values. So, and so on. So this is just a unique identifier for this characteristic, and it also has to be unique. So we can define our own custom characteristics, but they are not allowed to interfere with existing ones. So some of them are documented and defined as a standard, and some of them can be also defined by yourself regarding to certain sensors and things like this. So if we want to fetch data from a characteristic, we need to provide this UUID. So the smartphone is now simply telling, okay, I want to have this brush time, and this brush time has this UUID. So the smartphone is simply sending this request, okay, give me some data regarding to this brush time. and then the toothbrush is answering with those information. So we can have different type of access groups. So for example, this characteristics can be only read. This is just a read permission. Okay, then we can also have write. This means the smartphone is able to change those data in this characteristic, so within this toothbrush. Or we can have something like notify. Notify simply means the client has to be configured for this, but notify simply means every time a value changes, the toothbrush is automatically sending this information to this client, and the client can fetch this. This is quite popular regarding to certain sensors, or could be also the case regarding to brushing time or things like this. Okay? All right. Beside this, we have a lot of more options. For example, we've got requests that require a response, requests that do not require a response, and other stuff. But I guess for now, it's okay to have a high-level overview like this one right now. So over here, we have now summarized everything. The smartphone is asking the toothbrush, okay, what services do you offer? And the toothbrush is answering with the following, for example. If we want to fetch data from a service, we have to address this by the UUID. Addressing this UUID also requires certain permission. For example, this read, write, or this notify permission. Okay, so this is Bluetooth Low Energy in a nutshell. The key takeaways are, if you're using an external device, like this Ubertooth, then you have unfortunately to set it up 20 times to make sure that you definitely have fetched this connection. But if you want to analyze a mobile connection, then you do not need to worry about this. Regarding to our toothbrush, we do not know what those UUIDs means. What is the UUID for the brushing mode, the pressure, and things like this. To find this out, we have several possibilities. The first one is simply searching online for those UUIDs. So simply just take the hex string and put this into the search engine of your choice. Sometimes they have been documented in some SDKs and things like this, and you can find additional information. In our case, it is exactly this the case. So Oral-B, the vendor of this one, is providing an Android SDK where developer can write applications to communicate with this toothbrush. And this SDK has additional information, or let's even call it exact information, about the characteristics and their purpose. So I will show you afterwards within the Wireshark dump that we can match them regarding to the documentation online. In case if we cannot find any related information, we have to try harder. So what we need to do then is we need to repeat certain actions over and over again. And for example, turning it on and switching between those modes. And we have to do this quite often, really often, and then identify certain patterns. Often just a single byte changes, or we are requesting the same characteristic over and over again, and then we can figure out, okay, this UUID is serving the following purpose. All right? Okay. Weaponized with this knowledge right now, we will have a look into the existing Wireshark dump, but then we will also start hacking something. And the thing we are going to hack is this one. This fluffy, annoying little Furby. So this one is also communicating via Bluetooth Low Energy, and I will show you a really nice mobile application which is capable to fetch all this information, these generic attribute profiles and those UUIDs characteristics, and also gives us the possibility to send data to them. All right? Okay, so first let's have some quick look onto this toothbrush and then on this Furby. Let's go. Back at the Ubuntu VM, we now understand all of this a little bit better. And for example, we can see we've got here a response, and it's an attribute list. Okay, this is something we do not know right now, but we can see, okay, we are returning the following service UUID. This has the following characteristic UUID, and we can also see, where do we have it? Here we have it. Properties, notify, and read. So we are not allowed to write to this service or characteristic. Right now, we still have no clue what this one is doing. So as already mentioned, we can figure this out by ourselves by repeating those actions over and over again, or we can simply look them up online. Oral-B is providing an SDK for Android developers. Unfortunately, it's not available anymore. So on developer.oralb.com we can see that the store is currently unavailable. But if we take a look into the Internet Archive, which is a pretty good source regarding to things like this, we will find out that in 2022 only one state has been saved, and this is exactly what we're having here. So if we go back a little bit, for example in 2018, then we can see we've got a few saved states. So let's have a look at this one. Let's click on this snapshot. And now the Internet Archive is showing the site which has been stored at this given date. And there we go. The Oral-B developer program will be shut down on 15th of April. So I guess it won't be available pretty soon right now. Sometimes we can also find some cached files. For example, this SDK. Unfortunately, this time we are not that lucky. So if you're opening this link, we can see this URL has not been archived. The Web Archive itself, it's an amazing project and very helpful. So I have encountered some lost firmwares in the past regarding to the help of the Internet Archive. So you should definitely check this out if you're looking for something and the current link is not available anymore. Alrighty? Okay, back to the video. Okay, without having the SDK, do we still have a chance to identify what these UUIDs are? Yes, because if you're searching online for this, we can still find some references to them. For example, this UUID. So let's see, I do a right click and then copy, value, okay? Here I already have downloaded such a reference, and if you're now searching for this one, then we can see this one is now this service. And this service summarizes several characteristics, for example, this handle ID. But I mean, we do not have an exact definition what this handle ID is really doing. We do not have a certain description, I mean just handle ID, but here we can now see all these UUIDs and the things they are good for. For example, this one, if we read and value from this one and smiley appears on our smartphone. This is something we could trigger by ourselves with an external device, like the Ubertooth, which has been shown before. Okay, nevertheless, let's see if we still can identify this by ourselves. So within the introduction of this mobile application, I did brush my teeth very hard. So there were a lot of warnings regarding to the pressure of this toothbrush. So let's see if we can find this information in the Wireshark dump. Okay, and therefore I guess we have to scroll down because these packages, they should be sent quite often if we turn on this device and brush our teeth. So let's see. Here we already have many, but I guess that's, yes, okay. Here we had quite a few. Yes, all right, this looks good. So we can see all of them are regarding to the following handle. So this UUID, and we can see we are sending the value C0, okay? C0, 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 all right. Yes, 0 and what was the other one? 05. Is it the exact? No, this is a different handle. We need to be very careful regarding to this one. So we can see C0 and yes. So, whoops, sorry, on the left. So far, yes, okay. C0 and 00. So these are the two values we are sending to this characteristics. So let's see, oh, sorry, this service. So let's see what this UUID is good for. Okay, copy and then value. And let's look this up. And let's go down. Unfortunately, it's not regarding to this one. Oh, yes. Are those two the same? I guess not. Let's see. Yes. Okay, sorry, my bad. We can see perfect pressure sensor. This one is the service UUID and this one is the UUID we are sending those data. And if we have a quick look into this one, they look identical because these UUID, they have a certain prefix and everything also is pretty identical. Most of the time, just a single byte in their changes. Let's see. Copy value. I make a new one. This was the first value and let's also compare it with this value. And, well, okay, here yes, I've got it. This character. Let's see. Yes, just one single character. Instead of 0, it's B. So we need to be very precise when we look at those information. Okay, so here we can now see, yes, this is now the pressure sensor, and by getting maybe the value 0, everything is fine, and by getting C0, we are brushing way too hard. Okay? If we now want to attack this mobile application, we have to think in the following way. We've got our smartphone, which is running the mobile application, and we've got our device. So we could impersonate our device and then send arbitrary data to the smartphone. Or we could have a device and we can pair with this device and sending arbitrary data to this device. So we have to analyze both endpoints regarding to vulnerabilities or exploits in there. Okay? All right. In case if you have any questions regarding to this topic, please drop me a message underneath this video. And now I would suggest let's have some fun. Let's hack this super annoying little Furby. All right? Okay, let's have a look into this one.